Okay, let's see. I just thought I'd make these because I like them. I'm sure you're asking yourself, wow, how did he do all that? And basically, this talk is going to be a little less than useful, so I wanted to give you a useful tip up front. Basically, on your machine, do preferences, keyboard. And if you do that, you get a dialog, and you can add all of these. So they're basically little shortcuts. So when I type that on the left there, when I type face, then that thing comes up. So if you take anything away from this talk, it is that tip. Let's see, are there Concordia people here? Okay. Whoa, okay. I didn't know what that was. But he all says hi, so you should say hi back to him on Twitter. I was really excited to come here to CUSEC 2015. I didn't know that there were so many people out there who were John Cusack fans. Okay, how many people in here are 35 or older? Okay, we got a few people in here. This joke is for you. This next joke is for you. As a speaker at CUSEC, you can say anything. Anyway, so I want to talk a little bit about all the presentations that have happened so far. Some of the talks that I really enjoyed. I wanted to talk about every single talk that we've had here, but I just don't have time. So I'm just going to talk about a few of them. So first off, we started with Julie, and she talked a lot about imposter syndrome and about how I'm scared when I give talks, and it is very true. I am insanely frightened up here. But I'll tell you one hack for getting around that, and that is that I am incredibly passionate about what I do. I love teaching people, and I love speaking. Just, I am very scared. So I try to use those feelings to get over that. So you people who need to give presentations, use that. She also talked about imposter syndrome, which I think is very interesting. I am very lucky in that I don't suffer from imposter syndrome. And the reason I don't suffer from imposter syndrome is because I actually am an imposter. So I cannot suffer from it. So from Monica, I learned that she has a Justin Bieber Tumblr, which is really exciting. I went to that. Also, she was talking about how she gets American Netflix, which I think is really cool. I am able to get American Netflix, and I didn't have to do all that work. I'm not sure how that works, but I get it. We also learned that programs don't love you, but I can tell you that I love you. So I also learned from Mr. Helgate, doctor, that I may have a bullshit job, and that kind of frightens me. However, I've decided that I'm going to get into entrepreneurship, and I'm going to become a serial entrepreneur. So I'm thinking about joining, I don't know, General Mills or something like that. Then we saw Bruce, and now I'm afraid of everything. Everything ever. I really wanted to meet him. I didn't get to meet him. I wanted to ask him if I could get his signature on my PGP key. Then we saw Sandy, and I learned from Sandy that I am going to die. Basically, what I took away from this is #YOLO swag. So after all of these really, really great speakers that we've had at this conference, there's just basically one thing that I need to say to all of you, and that is please. The title of my talk is Description Coming Soon. It's not a mistake on the program. No, actually, I'm a terrible speaker and I forgot to set it. So actually, what I'm going to be talking about is the joy of programming. I want to talk about what they didn't teach you in school. Do we have any professors here today? Any? None? Wow. Okay. All right. That's fine. That's fine. So I'm going to be talking about science, magic, and then I'm going to wrap up. And you might be wondering, Aaron, why are you wearing a lab coat? And I want to tell you, like, your professors don't tell you this, but once you get into industry, it's common. What everybody does at work is they wear lab coats to work because that's what software engineers do, and I know they don't teach you that in school. Now, the other thing is that you might be saying to yourself, Aaron, how can you tell us what they don't teach you in school when you dropped out of college 3 times? And let me tell you to shut up. I'm actually a pro at dropping out of school. So if you have any questions about doing that. Anyway, my name is Aaron Patterson. I have come from the United States to bring you freedom. I was afraid I might be late to this talk because I couldn't figure out how to set my watch to metric. So I am known on the internet as Tenderlove. That is me. My Twitter handle, I am Tenderlove everywhere: GitHub, Twitter, Instagram, and Yo. So we got plenty of time. So I'm not going to tell you how I got my name, but I want to tell you about how my parents learned about my name. So I'll give you another speaking like pro tip. Thing that I do is like my mom is an electrical engineer, my dad's a mining engineer, my sister is a chemical engineer, and somehow my other sister is a dentist. I'm not sure. Anyway, so we're a pretty technical family, and I very frequently call my parents and tell them about my job. They know what I do. I tell them I'm a programmer. I explain everything there is about what I do to them, and I get a lot of practice with my talks. Like I go over all of my talks with my parents all the time. And I like doing it because they're very technical people, so it's fine if I talk about technical subjects. They can understand what I'm talking about. I mean, maybe they don't know the ins and outs of programming, but I'm pretty sure that, you know, anybody with a logical background can understand what we do, as long as we explain it nicely. So, you know, I tell them everything about my job, but I've never told them this. This is the one thing about myself that I have not told them. And I'm from Salt Lake City. I live in Seattle now. I've lived in Seattle for the past 15 years, but I grew up in Salt Lake City, Utah. My parents still live there, and I go home every year for Christmas. I don't really miss Salt Lake City very much. And there's a conference there, a Ruby conference there, and the organizer said to me, "Hey, Aaron, will you come give a talk?" And I said, "No. I did my time. There for Christmas, no." And he asked me several years in a row, and finally one year I thought to myself, you know, I'd actually really like it if my parents saw what I do. So I said, yes, I'll speak at your conference this year, but on the one condition that you give me 2 free tickets for my parents. And the organizer's like, great, absolutely no problem. So I go there, go to the conference, I meet the conference organizer, and I introduce my parents to him, and he's like, oh great, we have 3 seats reserved for you down at the front. And I'm like, okay, cool. So he takes us down to the front, and there's 3 seats in the front row. And there's a sign on each seat, and the first sign says Tender Love, the next sign says Tender Mom, and the next sign says Tender Dad. And I nearly died. I was like, okay, so I had to explain to them, I'm like, people know me by this name, don't worry about it. Everybody's going to ask you about it, just like roll with it, it's fine. So that's how they found out about that, and now they know. Oh well. I work for Red Hat. Specifically, I'm on a team called Manage IQ. Our team does cloud management stuff, so if you have a cloud, we can manage it. That's basically it. So all of you with clouds, we will do that. I'm a 0.125x programmer. So yeah. I'm on the Ruby core team and also the Rails core team, so I'm the only person that's on both teams actively. And recently I purchased the Google Glass, which is really exciting. I don't know how many of you have Google Glass, but I'll show you, I'm going to show you a picture of it because I really love my Google Glass. This is it. It works really well. I mean, so I do love it. I have a couple cats. This one her name is Choo Choo. Is one of them. My other cat, his name is Gorby Puff. And I was going to tell you that I have cat stickers, but I do not. I ran out of them. I'm really sorry. I also have, so I wanted to say, like, I'm actually a very shy person. I'm a really shy person, and it was interesting to me that somebody at one point came up to me and said, Aaron, you know, I was actually really intimidated to talk to you because you're so famous and you're actually a really nice person. And I was like, well, that's interesting because I'm intimidated to talk to everybody. But my hack for this was essentially that I made a bunch of stickers of my cat so that, like, if anybody wants to come talk to me, they can say, hey, Aaron, can I have a sticker? And I can say, yes, you can. Let's talk about cats. So that was my hack for that. And I brought a bunch of them, but they are already taken, so I'm sorry. Instead, if you want to come talk to me, I'll give you a hug instead. So we can do that. I also have a moss ball. Her name is Ogawa-san. My wife and I took some holiday pictures. I wanted to share them with you. This is one. This is the other one. I'm really excited to be here in Canada. It's really exciting. So I've been to Vancouver, but that's the only place in Canada I've ever been. This is my first time in Montreal, so I'm really happy to be here. Except for the cold, which is, it was minus 21 degrees C, I think, which is minus 6 degrees F, or 6 degrees freedom. We refer to it in the United States. Also, I wanted to let you know that, like, my view of Canada is a little bit skewed because everything I know about Canadian culture I learned from the Red Green Show. The women don't find you handsome, at least they'll find, or hopefully they find you handy. I don't remember. I'm nervous. Okay. So, all right. CUSEC 2015. I had to study this. It stands for Canadian University Software Engineering Conference. So is everybody here are software engineers or computer scientists? Is that that's what's going on? Okay, so is there a difference between software engineers and computer scientists? Yes. Yes. Oh my God. Did I mention that Did I mention I dropped out of college 3 times? So we're computer scientists or engineers. So today we're going to be talking about science, which is why I'm wearing this lab coat. So as all of you know, I mean, I'm sure all of you are scientists and engineers, so I'm sure all of you are aware about the scientific facts of homeopathy. And what I want to talk to you today about is homeopathic code optimization. So for those of you that don't know now this is a technique that I've pioneered myself. And for those of you that don't know what homeopathy is, I'm going to go talk about it a little bit. And basically, what it boils down to is diluting stuff until it is very, very tiny, and the tinier it gets, the more effective it's supposed to be. And in order to research this, I did what any good scientist does. I went to Wikipedia. Now, the main problem with going to Wikipedia is that I found that this article is just way too long. It's just too long. So I'm going to teach you another trick, which is essentially if you highlight all this text, what you can do is you can right-click on it, and we'll zoom in there on the menu, and you'll see it says Summarize. So this is basically my trick. What it is, you click on that, brings up this text box, and you can summarize the whole thing. So this is essentially what the summary is. I guess I'm not sure if it's diluted or not. This is a summary. It's all about dilution, but essentially what it is that water has memories. And water remembers the substances that were mixed into it, which I love the use of quotes. But anyway, so water has memories, right? Okay, we all know that. We're all scientists. Memories. And the more diluted something is, the more powerful it becomes. Makes sense, right? So my question was, I was sitting there thinking about this, and I was just thinking, well, you know, can white space have memories? And the answer is yes, absolutely. White space can definitely have memories. So I'm going to show you a demo of it. This is the recursive Fibonacci sequence. So this is Fibonacci. This is the way that you benchmark a language. Like, this is the de facto way. Scientists. So I'm going to give you a little demo here. Basically, I have that code here. There is my Fibonacci sequence, and if I run the dilution if I run it, you'll see, okay, it outputs 34th Fibonacci number. And if I run my dilution program on it, you'll see that some of the text disappears. Each character has a 10% chance of disappearing, but yet it's still runnable. I can run it. So, and I can dilute it even more. So let's dilute it more. I don't remember how many times I dilute it here, but we'll see. Let's see. Ah, there we go. We're disappearing a bunch of those, and you can see it's still executable. Do I do it 6 times? I think I do it 6 times. If I remember correctly, the Wikipedia article says that like 6 times is optimal. Like, that's the optimal amount, and that's what we're really trying for, is the optimal amount of code dilution. Counting that up there. Ah, that's the 6th one. There we go. Good job, Aaron. Past Aaron recording this. Okay. It still works, I think. Yes. All right, good job. Did I change it anymore? I think that was it. All right, good job. Anyway. Oh, no. There's more. Oh, yeah. So I wanted to prove that I wasn't bullshitting you. This is for real. This is legit. So I changed it so you can see that it's indeed actually changing the output. So this isn't, I'm not messing with you. This is real. This is for real. So you might be asking, how does it work? And I will tell you how this program works. The way that it works is that the virtual machine remembers your code. Okay? It's not white spaces, it's memory. So just like keep that in mind. So, you know, the Wikipedia article talked about dilution power, and 2C, so 2C dilution is 1 part in 100, and 6C, that is our best one. That's 1 times, or 100 to the -6th. So our 10C is a 10% chance of deletion, right? I want to take a little bit of, a tangent and talk about some of my favorite programming languages. Some of my favorite programming languages are the weird ones, and I want to show you a few of those. One of them is called ANTI. This is a programming language that's all based on cards. So that's an actual program that prints out "Hello World." There's another programming language called Type. This is my favorite, one of my favorites. This picture is actually a program, and the way that it works is that the interpreter walks through the pixels of the picture and interprets it. And this is a Hello World programming Type. I forgot to mention this. This talk is like rated NC or rated R for language, because we have another one of my favorites, Brainfuck, here. So this is another Hello World program, and one of my most favorite programming languages is called Whitespace. This is it, or is it? We don't know. Anyway, if you go to that page, you can go read up on it. This is actually the Hello World in Whitespace. I know you can't see it, but it's really there, I promise. So thinking about this, we have the homeopathic dilution rate, and I added a homeopathic dilution rate to this program, such that if we run, I can say like there's a normal Fibonacci sequence, and I'm going to add a dilution rate to it. You'll see there's our 10C dilution, but I can increase that to, what am I going to do? I don't remember, 50%. So each character has a 50% chance of being deleted, and it still works at 50%. And then we can actually go, can I do 100%? I think so. 90%? Oh, okay. Show off. Who is this guy? Then we do, come on, do 100%. There we go. So 100% dilution. And it still works. So what's interesting about homeopathic code optimizations is that it safely degrades to the white space line. Now, the benefits of doing homeopathic programming are that it's faster. It's absolutely faster. And the way that we can know this is because of this one axiom. No code is faster than no code. Right? So the more diluted it is, the faster it becomes, obviously, right? We had no code. You saw there was no code. It must be faster. So I'm going to show you the benchmarks. I made benchmarks about this. So basically, I'm just using time. This times the normal Fibonacci sequence. So it takes about 1.6 seconds. Then I'm going to dilute it, and I'm going to redirect that to a file because I don't want dilution time to offset our benchmarks, right? This is scientific. Then I run it. And this took 1 point. I guess it's slower this time, but usually it's faster. So it's faster. Just trust me. Now the thing is, this is also more maintainable, and the reason it's more maintainable is using diluted programs is more maintainable because there's no code to maintain. Right? So it makes sense. Less is more. Okay. Now, you may not know this, but I actually run a consulting company called Adequate Industries. We do everything adequately. And we've licensed this technology today. It's available for you to buy. I mean, so I'm wondering, how much would you pay for this? $200? No? No? $100? Well, let me tell you, today it's on sale. I put it on sale. We've got it on sale, 2 easy payments of $49. So come see me later. You can buy it. We also have discounts for enterprise installations, so if you're at an enterprise company, you can use it. So, all right, enough of that. We're going to talk about magic. The Gathering. Watch out, there's actually some code in these slides, so be careful. So, for those of you that don't know, Magic the Gathering is a collectible card game. Okay? Now, recently my friends started playing Magic the Gathering, and I wanted to play too. They invited me to play and said, hey, Aaron, would you like to play Magic? And I was like, yes, I would love to. Except that, you know, I have a closet full of cards. I played Magic maybe, I don't know, 10 years ago or something, and haven't played since. And I got a closet full of cards. I'm like, yes, I would love to come play a card. You know, I'd love to come play with you. But the problem, I had a lot of problems. I go dig out these cards, and I counted over 5,000 cards in my closet. And that is a small collection, for those of you that don't know. So my problems were that I had too many cards, and I didn't know what any of these cards do. I didn't know if they were worth any money. And there's a lot of other issues, like how do I build a deck? Like what do I do? What do I do with all these cards? And I don't want to read through all of them and figure it out. It seems like a job for computers, right? Figuring out all this stuff seems like a job for computers. So I built a program to solve this problem for me, and I want to talk about that program today. I'm going to talk about my solution and share it with you, and hopefully you can do this with your Magic cards as well. Magic Gathering cards. So we're going to use artificial intelligence, cameras, and cats in these slides. So I'm going to go over the high-level solution to this, the specific implementation, and then future work that I want to do with the system. The high-level process goes a little bit like this. I want something cheap and something easy. And I got cheap, but I didn't do easy, and you'll see why. So what it does, essentially, what my system does is it takes a photo, it extracts the card, the magic card from that photo, then it identifies the card, saves the data, and then just basically does that over and over and over again. So we just have this loop, got a card, hopefully work through all my cards this way. So I'm going to talk about each of these particular steps. Now the first step is card identification. So we take a photo and we need to identify that card. So how do we do that? The way I do it is I have a corpus of information. So I populated a database with a corpus of information. My system attempts to make a guess about what that card is. And it asks me, hey Aaron, did I guess correctly? Is this the right thing? And I say yes or no. And depending on my answer, that teaches the system. And the corpus grows after I teach the system. Then it makes another guess, and we just keep repeating that loop until our corpus gets larger and larger. Is that, oh man, come on. All right, guess, prompt, teach. Each time we go through the system, the amount of knowledge gets larger and larger. So the system gets smarter as we go on. This is our artificial intelligence. So I want to talk a little bit about the data model for doing this, and then we'll get into the specifics of card identification. the data model. So I thought, I need to go gather some information. I need to gather information about these cards. So I did some information gathering. I can't stop. I can't. Anyway, so I need to get a database of cards, and the way that I got the database of cards is I got it from the Magic the Gathering website. So I needed the important information that I needed was I needed the card name, I needed the image of the card, I needed the set that it came from, and the reason I need that is because the same card can be printed in multiple sets, but depending, the set changes how much the card is worth. So it's important to know what set it came from. And then I also wanted the rating because I needed to answer the question of like, how good is this card, right? So I want to talk a little bit about, do I have time to do that? I do have time. Okay, so I'm going to talk a little bit about promises in Ruby. Promises. So let's go over some promises. What are promises? Promises essentially deferred calculations. So we say like, okay, promise new. Inside that promise, we can say like, what is your status? So it's doing, that promise is doing some work. We can ask at the end when the promise is finished, we can ask what the value is, the computed value. So after it's done calculating that value, we can say, hey, what is your value? We can also ask whether or not the promise is alive. Is it still, which means, is it still running or has it died? Has it finished? Or we can do promise.raise to cancel the operation. And when we ask for the value, the promise blocks until it's done, right? So if we try to ask for the value, it'll say, it'll just sit there and wait until the promise has finished computing the information. So I'm going to show you the implementation of this promise system in Ruby. That is it. That's the entire implementation. The problem is that you can get into a situation where you have too many promises. Like we can't create an infinite number of promises, so I needed to create a system that limits the promises. And I'm not going to go too into detail about this code. It's going to be small, and you probably don't care. But this is an executor pool of executing a bunch of promises. So essentially, what it lets me do is it lets me say like, okay, I'm going to have a pool of these promises or threads, as we may call them. I want to have a pool of them, and I want them to go do some work for me in parallel. That way, I can limit the number of stuff that I'm doing in parallel to just the number of cores on my system. So this is what the executor pool looks like. You don't need to read that. This is what the promise looks like. Essentially, I say like, okay, create a promise, which goes to the executor pool, and when I ask for the value, and when I tell it to run, it'll actually run your job. When I ask for the value, it'll wait until your job is done, and give me the value back. So then I can queue up some work. Oh, right. So I release that. The way that this works is it releases the latch and then returns the value when you have two separate threads using the promise at the same time. So with that, I can queue up some work. And I can say like, okay, I'm going to go download all of the information from Wizards of the Coast, scrape their entire website, get all the magic cards, all that data, and I can do it all in parallel. So in Ruby, in MRI, you can do I/O operations in parallel, which means that truly in parallel, which means that I can do web requests in parallel and do as many as I want at the same time. So this is really exciting to me. I could queue up this work, download all these images and information from Wizards of the Coast website. So I did that, and this is what it looked like. That was me at the computer. I was really excited. And all these lines going out to Wizards of the Coast. That was really amazing. And then, so that was my computer going to Wizards of the Coast. It was really cool. So I downloaded all this data, got it all downloaded, checked it out. It was 1.6 gigabytes of data. So a lot of data. And I was able to download that in, I think, in about an hour or so, an hour or two. So I'm pretty sure Wizards of the Coast might have noticed. So anyway, I did all this stuff. Like, I did all this, downloaded all this information, loaded it into a database. And I was talking to my friend about this, telling him, hey, I got this system. I downloaded all this information from Wizards of the Coast. I wrote the program. You can use it for your, if you want to build a database too. And he responded to me, well, have you heard of this website called mtgjson.com, which has all of that information in a JSON file that you can just download. And I was like, I said some swear words at that point. I won't say them now, but I said them then. So the moral of the story is try Google first. If you come across a problem, just type it into Google. I don't know if they teach this to you in your software engineering class. It's very important. The other thing, actually, you know what class I think they really, really need to teach in school is how to read Stack Exchange or Stack Overflow answers. I'm serious. Because sometimes I'll Google for a problem, and then it comes up with a Stack Overflow answer, and I read the top one that's most voted and checked, and I'm like, no, that's totally wrong. That is bullshit. And then I find the actual correct one that's a few lines down. So people need to learn how to read these things, because that check mark doesn't mean that it's right. Anyway, so now that I've learned my lesson about trying to Google first, I'm going to talk about the data model of my database. The data model, at first I was like, okay, we got an image. An image goes to a card. We've got a one-to-one relationship, right? So an image belongs to card. Card has one image, no problem. No problem, until I came across this card. This is one card that has two images. So I was like, okay, crap. I need to redo my database. So I did that, and I was like, okay, cool. So one card can have many images. That's fine. All right? Good with that. So I went on, continued processing this stuff, and then I ran across this card. This is two cards with one image. So I had to redo my database again, third time. All right, I got it. Image has and belongs to cards, has and belongs to cards, and it's actually more complicated than this, but I'm not going to go into it. This is how my database is set up. So essentially what the database looks like is we have a list of cards, we have a has and belongs to many relationship with images, and then we have a has many relationship with hashes. And I'm going to talk about hashes a little bit later. Well, I'm going to talk about them now. A little bit later being now. So the way that recognition works in this system is that I take a perceptual hash. And now, what a perceptual hash is, well, some people have asked me, why didn't you do OCR on this? Like, read the characters off of it, and then you can figure out what the card is from that. And I found that OCR was very, it wasn't very reliable, so I went with a hashing system. And the way that this hashing system works is you take two images like this, and you say, hold on a minute. I'm upset with my computer. Go. Is that better? I think that's better. All right. So we have two images, and both of them, we get a hash from both of them, and that's that number down at the bottom. So the left-hand side is our reference card. That's the one that I stupidly downloaded from Wizards of the Coast. The one on the right-hand side is the scanned image, the one that I have, right? Now I take these two particular numbers and I can put them into a Hamming distance function, and I can calculate the distance between those two images, saying like, what is the difference between these two images? And I get this value out of it that's 8. And what this is calculating is like, how different are these? And the lower the number is, the closer the images are together. So if we take two images that look like this, which are clearly different, we get these two numbers out of the bottom. We got our reference card on the left, our scan card on the right, and we calculate the Hamming distance. You'll see that it's a much higher number. It's 28. So we know that, okay, we can get this hash, compare it to all the hashes in the database, and then find the one that's the lowest, and that's going to be probably going to be our match. So unfortunately, this isn't always correct, and the reason is because when we download those images from the internet, who knows what the lighting conditions are? They're probably better than the lighting conditions in my apartment with the crappy webcam that I'm using. So what I do is I say, okay, well, if it is correct, if I tell the system, yes, that's correct, it adds the hash to the database, and we increase the knowledge, and the next time we come across that card, the distance will be even smaller, and we'll be more confident about the match that we make. So adding hashes increases the knowledge in the system. So I like to call my system the freestyle environment solution. And I'll show you what I mean by that. This is the system in my house. There's my laptop there. And what I did is I built a little light box. You'll see the light box on the right. and I got a little light going in, and then I've got a camera there. I zoom in on the camera, so that's my camera pointing down into the light box, and you can see it points right at the card. So this is from behind the camera. So essentially, what I do is I put the card inside, and then the system recognizes the card and catalogs it, and then I can just keep doing it. It's kind of a manual, like fairly manual type environment. I have to keep moving the cards. So the advantage of this system is that it's easy to set up. I just have this light box and a webcam. I plug that in. It's done. Very little hardware. It's very cheap. I mean, it just had this webcam lying around, and you don't need to calibrate the system at all. It just recognizes where the card is. The disadvantages of this is that it has incredibly complex software. I told you my system was cheap, but it was not very easy, and I'm going to talk about that later. And we have to do manual labor. Like, I actually have to go in there, and I'm like switching cards, and there's a cat in the way. And there's slow identification as well. So the software that I use for this is OpenCV. I'm going to talk about how we do that, or I did that. And what I'm using OpenCV for is when I take a picture of this light box, like this is what I have. That's what it looks like, right? That's directly from the webcam. Now, unfortunately, that's not what I want. What I want is I want something like this. I need a rectangular image so that I can compare it to the original. So the original being on the right like that. So we have to be able to identify that there's a card in the image, extract the card, and then resize it and shape it so that it's the same size as the same shape as the reference card. So we have to do card extraction. I'm going to do that in 8 easy steps. These may not actually be easy. So the way that we do this is we pre-process it by saying, okay, I want to get a grayscale version of the image. So we grayscale the image, and then it looks like this. Then you can ask OpenCV to give me, do a canny edge detection. You can look up what canny edge detection is on Wikipedia. I read it like a good scientist, and I still don't understand it, like a college dropout. So it produces an image that looks like this. You might not be able to see it, but there's little white lines in there. Those are the edges. Those are the edges in the card. Those are the edges that OpenCV sees. What we want to do is we want to be able to find contours in the image. And unfortunately, we have things called holes. And you might be wondering, like, what is a hole? A hole you can think of as like a donut hole. If you're scanning a donut, the outside of the donut would be the contour, and the inside of the donut would be a hole, right? What do they call this here? It's not donut holes, it's something else. Timbits. That reminds me, I need to go to Tim Hortons. I haven't been there yet. Anyway, so we have, on the outside of the card, we have a contour, and that little box inside there would be considered a hole. And if we map those contours over, this is what it looks like. So what we want to do is we want to find the contour that's the largest one, because that's what our card is. That's the largest contour in the system, so we can do it this way. We say, give me the largest contour by the contour area. And you might not be able to see this in the image, but you'll see it. The contour is a green line. I plotted it around that. Then you can ask OpenCV, calculate a polygon for me. So it calculates a polygon, and we create a convex hull, and we need to get the points of that polygon in clockwise order, so I'm reordering them to be clockwise. And let me tell you something that really, really sucks about OpenCV. One thing is documentation. Documentation is really, really terrible, and then I found a book on OpenCV, and the book on OpenCV is written by the people who wrote OpenCV, and I was like, why don't you just write the documentation? Why do I have to buy this book? Anyway, I started reading the source code, and you can ask for the polygon to be in clockwise order, to give you back the points in clockwise order. So what I did is I said, give me the points in clockwise order. It has a constant. It specifically says clockwise order. And when you get the points back, they're in counterclockwise order. I don't know why. This really, really annoyed me, though. Anyway, so I had to reorder them. And this is what it looks like. So we have those 4 dots around the edge. That is it. That's our card in the image. Okay? Now the final thing that we need to do is we need to be able to warp this image so that it's no longer, I guess it's like a trapezoid or something kind of weird. It's not a rectangle. We need to be able to warp this image so that it's a rectangle. So you have to build a warp matrix. So you can say, OpenCV, give me a warp matrix to warp this image to be this certain size. So you build a warp matrix. It doesn't stop. It doesn't. I can't stop it. So you warp the image. Tell OpenCV, hey, warp the image for me. It faithfully does it. This is what the output looks like. Then we set the ROI, or region of interest, to crop it. Then crop the image, and finally we get that out. It's just that easy. Folks, it's just that easy. So I want to show you a video of it in progress. So this is what it looks like on my machine when it's running. Hopefully, okay, auto started. You can see on the right there, I'm putting a card underneath. On the left is that's video output. So the very left image is the image coming from the camera. The image to the very right of it, that's what the system thinks it is. Okay, so as it goes to the right, those guesses are worse. Okay, so let me replay that for you just so that you get it. This image on the far left came from the webcam. Those images, those three images on the right, are what the system thinks that card is. So I can tell it, hey, you're right, or you're wrong, or whatever, and it gets smarter. So with all that done, I can now say, I can now ask, what do I have? Tell me what cards I have in my library. So I can get that. And now that I know the ratings for everything, I can say, how good are they? So sort by best. And I can also ask, what is the worst card that I have? So I'm going to tell you my best and worst cards. This is my best card. For those of you that play, or those of you that don't play, this is a very good card. This is very good. This is my worst card. Even people who play probably don't know what this card is, and that's because this card is really, really horrible. It's super funny to read the comments about this card. Anyway, so future work that I want to do with this, I want to be able to graduate my machine. Like right now, I have to tell it, like, yes, that's correct. Choose that image, or choose, or you're wrong. I have to tell it all this information, and it gets once I train it for a while, it gets to be about 80% accurate. But still, 20% wrong is kind of a large area. What I was thinking is maybe incorporate Mechanical Turk. So I could be like, okay, if system, if you're 95% confident what this card is, that's fine. But if you're only 80% confident, let's upload it to Mechanical Turk and have a human do it for a low price. The other thing that I want to do is I want to have it build a deck for me because I am lazy. I don't want to figure it out. I'm just a casual Magic the Gathering player. Also, the other thing I want to do is I want to be able to use this for pricing and commercial applications. So, I want to sell my cards. Which cards should I sell? I mean, I have thousands of cards that I don't use. I should probably sell them. So, I would like to wrap up my talk. I'm sure you're asking, Aaron, what is the point of all this? You showed me homeopathic programming. It's science, and we are scientists. And then you showed me Magic the Gathering. What does this have to do with me? I am a student who is going to graduate soon. Why do I care? So the thing is, the stuff that I'm showing to you isn't random. This isn't random stuff. I didn't just say hey, I'm going to show you some random things that I did that I think are fun. Though I do think they're fun, and they are random things, but that was not my thought process. The point that I want to make with these things is that I think even in software engineering or computer science, I think that creativity is essential. It's essential to our jobs. You're going to be entering a marketplace where you have to identify issues with systems, deal with crappy code, solve problems. You're going to have to do it creatively. I think that programming is a creative profession. We do a lot of science stuff. I know that you do a lot of scientific work in school, studying algorithms, figuring out complexity, code complexity, and those types of things. But I think that that's maybe only half of our jobs when you actually get into the real world. Once you get into the real world, you need to be solving problems that nobody has solved before, and you're going to have to think creatively, which is why I showed these things to you. I want you to be thinking creatively and come up with creative projects. You're going to have to deal with legacy code and say, what is this crap that people wrote before me? In fact, I guarantee that 100% of you are going to have to deal with legacy code. I guarantee it. Okay, how many of you out there are going to be entrepreneurs and write a brand new application? That's great. I'm sure you're thinking to yourself, I'm not going to have to deal with legacy code, but let me tell you something. Day 1, you will not deal with legacy code, but day 2, you will. So 100% of you are going to have to deal with this crap, right? And you're going to need to be thinking creatively about these problems. Also, you're going to have to use this for problem solving. You're going to come across new problems, and you have to solve it creatively. So I want you to exercise your creative minds. So finally, I'm going to say something useful. I know that I'm talking to computer scientists and engineers that are about to graduate, and I thought to myself, you know, when I was your age, what would be the most beneficial to me? Like, what would help me the most? And I'm going to give you, this is probably lame, I don't care. I'm going to give you some book recommendations besides Sandy's book. You already got that. You saw her talk, and you should be buying it, right? Everybody's bought a copy? Okay, good. Good. I'm going to give you some other book recommendations, which if I had had these at your age, I would be much better than most software engineers out there. You need to get this book. This is my favorite book ever. Just buy it. Just do it, okay? It talks about C++ and Java, but that's not the point of the book. The point of the book is working with legacy code, and it actually teaches you how to think creatively when you're dealing with legacy code and how to solve problems doing that. And I guarantee all of you will be working with legacy code. You need this book. I'm pretty sure they don't teach you how to deal with legacy code in school, even though I dropped out 3 times. The other 2 books you need to get are these 2, Java Concurrency and Practice. I'm not a Java programmer, but this is extremely useful. And also, you should read that one on the right and actually do the problems in it. It's very difficult, but you need to solve it. That is all I have for you. Thank you. Keep your stick on the ice. I'm pulling for you. We're all in this together. Does anyone have questions? Questions? We have time. I only did 47 minutes out of my 50. Fast.
So I thought that was really great.
Oh, thank you.
My question is in 3 parts, though.
Okay.
So, have you ever heard of spirit science? Was this at all inspired by it? And do you have a critique on it?
What is? I don't know.
Spirit science? Okay, well, spirit science, basically look it up on YouTube. It's a bunch of basic science kind of mixed with a whole bunch of conspiracy theories like Atlantis and all this kind of shit. It's amazing, it's hilarious.
That stuff is great. No, I was inspired by, why was I inspired to do this? I don't know. I don't know. No reason. I just thought it would be funny.
That's great.
Did you ever get to playing Magic the Gathering, or did you just create a program?
That is an excellent question. I should talk about how long it took to build that stupid thing. That took me, so that program took me, and you can find it on my GitHub, it took me maybe, I don't know, at least 80 hours to build, at least. And I did get to playing Magic the Gathering, but I didn't use any of my old cards. But I found cards, like using the system, I actually found cards that were worth like $100 each. So I was like, oh, nice. I guess I can't use these. Yes?
Are you going to release this program when you're more or less done? Because
Which one?
The Magic the Gathering.
Oh yeah, it's on my GitHub. You can get it.
Oh, okay,
You
cool.
can get it today. It's incredibly difficult to set up. I need to work on simplifying it. That OpenCV stuff is just horrible. So a friend of mine built a similar system, and we kind of worked on it together. His system is a little bit better. He built a hopper out of Legos. So what it does is you put in a stack of these. You put in a stack of cards, and the hopper sends a card down a chute, then it lands at the end of the chute, and then he has a camera that's mounted in a fixed position at a 90-degree angle right above the card. And the advantages that that gives him is that his card is always in the same place in the image. And since it's at a 90-degree angle, it is always rectangular, which means that all he has to do is crop the card out of the image. He doesn't have to do any of this crap that I showed you, like this. I don't have the patience. I have the patience to work on OpenCV, but apparently not for Legos.
So why didn't you use that?
Why didn't I do Legos?
Why did you use his project?
Why did I use this?
Why did you not use his project?
Oh, why did I not use this project? I didn't want to put together all the Lego stuff. You gotta buy Legos. See, one thing I love about programming is, to me, programming is essentially the same thing. Like, it fills the same place in my heart that Legos did when I was a kid, except that I don't have to clean anything up. That's basically my problem. I have horrible memories of stepping on Legos barefoot. I know you've done this before. It sucks.
So my question is, did you end up selling the cards, and how much money did you make selling the cards? And if you were to divide the amount of money by the hours you spent doing it, how many dollars per hour would you have made?
Okay, so you guys are asking some very pointed questions.
I have a follow-up question too. So
That make me feel bad about this project, because I didn't sell any of them. And beyond that, the ones that I found that were like $100 each for those of you that play, they're Sacklands from Onslaught, and they're worth a bunch of money, but just the recent set just came out with a bunch of Sacklands, so the price just tanked on these, and I don't actually know what they're worth today. So I didn't sell any of them. So I got, what is $8 per hour, so 0 divided by 80. You're a scientist, you can figure it out.
Hello.
Hey.
One of the books that you pointed to towards the end is this Lisp book.
Yes.
Why is this a good book to read? Especially if it takes so long on the outside and like Lisp doesn't really feel like most computer work things these days.
Lisp is amazing. Because Lisp is awesome. No, so you might be programming in Clojure. The reason that I like this book a lot is because it goes through the entire process of, you're not just learning Lisp when you do this book, you're also learning compilers and interpreters. So you actually learn how to compile the Lisp into a machine. Then you also learn how to build an interpreter for that machine. So I think it's very interesting.
It is super cool.
Thanks. So I think it's just entertainment and very interesting. If I had to say, like, buy one freaking book, it's that one. Like, that is the one. You need this for your job.
So how do your cats feel about Magic the Gathering?
They freaking sleep on the cards. They sleep on the cards and mess everything up. They don't seem to care, and I have to hide it from them. They really like the boxes is the thing. Like, they love the boxes that I store them in, so they'll sleep on that. But yeah.
Thank you.
You're welcome.
Hi, so I have a similar problem. I'm always saying really bad puns. Do you have any advice as to how I could like fight that or maybe improve my level of quality of puns?
No, I have no advice for that, but I do have a story about telling puns, and it's like, so I'm actually not very good at it, I found out recently. I went to a conference where they had a pun off, like it was a punning competition, and I thought, oh, I got this in the bag. But they brought in 2 people who are professional punners. So this is what they participated, like they're the world's best punners, apparently, in Austin. So we had a competition, they came up, and I got destroyed. I couldn't think of anything, it was horrible. So no, I have no advice for you. Maybe talk to your parents more.
Thanks.
Yeah.
Thank you, Aaron.
You're welcome. Thank you.